Hi everyone, in this video we're going to be looking at quadratic inequalities. So first of all, what is a quadratic inequality? A quadratic inequality can be written in the form, and let's write them all down. So if we have a quadratic in standard form, it can be greater than or equal to 0, greater than 0, less than or equal to 0, or less than 0, where a does not equal 0. And in this lesson, we're going to be using sine diagrams. So a sine diagram is a number line which indicates the values of x for which the function is negative, 0, positive, or undefined. The sine diagram consists of a horizontal line which represents the x-axis, positive and negative signs indicating where the graph is above and below the x-axis respectively. And the zeros of the function, which are the x-intercepts of the graph. Okay, so those are all the definitions. Let's look at some examples. So first of all, I have an example of some sine diagrams here. So we have the function, we have the graph, and then we have the sine diagram. It's just demonstrating what's happening. So for the first function, we have zeros at -2 and 1, and so that's what's going to be marked on the sine diagram. And all we need to know is where's the graph above the x-axis? We're going to say that that's positive. And where's the graph below the x-axis? We're going to show that as negative, and again, positive, positive. Right? In the second example, we don't cross the x-axis at all. So we have no markers like we did in the first example. We're just going to simply say that the graph is positive everywhere. So it's above the x-axis everywhere on the graph. And for the next graph, we only touch the x-axis in one place. So we have one marker on our sine diagram. Before and after that marker, we're below the x-axis. Right? So first we're going to practice drawing a sine diagram given a graph. So what do we want to do here? We want to set up our line. We're going to put the values where we cross the x-axis. In this case, we're crossing at -3 and 5. And then we're going to use positive and negative signs to indicate below or above the x-axis. So we are below here and here. So we're going to do negative, negative. And we're above between -3 and 5, so that's positive. Okay, I would suggest pausing the video and trying the next one on your own. In this case, we have one point where we're touching the x-axis at -1. And before and after -1, we're above the x-axis. All right, for number 2, you're going to not only draw the sine diagram, but you're going to do a quick analysis of what the graph would look like. Well, in order to find out what the x-intercepts are, we want to set our expression equal to 0 and solve for x. So let's go ahead and do that. Also, it's important to note that this graph has a positive value of a. A is greater than 0. So we know that we're looking at this situation. You could also put this in your calculator, but so we're going to set this equal to 0 and solve. In this case, we're going to get x plus 3 and x minus 1. So we know that our x-intercepts happen at -3 and 1. So that's easy, all right? So we're going to go ahead and sketch our sine diagram. We know that we have markers at -3 and 1. And because we know that our graph is facing up, we know that before -3, we're going to be positive. After -3 and before 1, we're going to be negative. And after 1, we're going to be positive. Now, the other thing that you could do is you could set a value that is less than -3. So let's say we say x is -4. And we put that -4 into our quadratic expression. So we're going to get -4 squared plus 2 times -4 minus 3, right? That's going to give us a value of +5. Well, 5 is greater than 0, so we know that it's going to be positive. And so you could certainly do that for these as well. All right, now moving on to letter B, we know that we have a value of A. We know that we have a value of A of less than 0, so we know that we have a graph that's going to be upside down. Right? The next thing we're going to do is find the zeros. So let's say we've got -4, x minus 3. Really, x minus 3 squared is the same as x minus 3 times x minus 3. So it's already in factored form. So we know that we have a 0 at x equals 3 because the zeros for both of these factors is 3. So we know that our graph is only going to touch the x-axis in one place. So it has to be that scenario. It has to be that picture. So let's draw our sine diagram. The only value is 3, and before 3 and after 3, we're negative. And again, you could also use the technique if you're not sure. Certainly, you can use your calculator, or you could put a value that's less than 3 into your expression and see what value you get. So let's say we really just wanted to check to see, is it really negative over here? So if we put a 4 into our quadratic, let's go ahead and do that. A value of 4 is just a number greater than 3. It has to be past the value of 3. Okay, that's going to give us -4. That's less than 0. So we know it is negative. Okay, so far so good. All right, here's where we really get into really the whole point of this lesson. We're trying to learn how to use sine diagrams to help us solve a quadratic inequality. So first thing we want to do is shift all the terms to the left side if they aren't already. Fully factor the left side, or some people say factorize the left side. Draw a sine diagram, and then determine the values required from the sine diagram. So that's the part that's probably going to be mostly new to you, is that last part. So let's go ahead and first of all shift all the terms of this first one to the left side. You have to subtract 2 from both sides. Right now we're going to factor this. We're going to solve for x. We're going to set up our sine diagram. The value of -2 comes before 1/3, so we want to do that in order. Okay. Now we do know that we have a quadratic that has an a value greater than 0. So we know that we're pointing up. We have two intercepts. We have an intercept at -2. We have an intercept at 1/3. So we know before it'll be positive, after it'll be negative, and then after 1/3, it'll be positive. What we're trying to do is we're trying to find values of the quadratic that are greater than or equal to 0. So where is this quadratic greater than or equal to 0? So that's wherever it's positive, wherever it's above the x-axis. So the solution for this then would be wherever x is less than or equal to -2, or where x is greater than or equal to 1/3. That's our final answer. That's our solution. So let's circle that. All right. And we just want to make sure we note this is either or situation. Okay. Now it was less than or equal to or greater than or equal to because our original quadratic inequality used an equal with the greater than symbol. All right. If I were you, I would pause the video now and I would try letter B. So first of all, we're going to put everything on the left side, move that 6x over, so subtract 6x from both sides. Notice we have a less than, but we don't have a less than or equal to, so that's important. We're going to factor this. Right, so the intercepts are going to be only at x equals 3, because both of those give an x-intercept at x equals 3. So let's draw our Sine diagram. We know that our parabola is facing up because we have a value of a, right? A is greater than 0. We know that we're only touching in one place, right? So we have a positive, positive before and after 3. Now we're going to go ahead and think about solving this. So we want to know all the values where x squared minus 6x plus 9 is less than 0. Well, looking at our Sine diagram, right, we can tell nowhere is it less than 0. So this inequality is not true and there is no solution. All right, so there's lots of practice here for you to try. My suggestion, as always, would be to pause the video, try them, come back when you're ready to check your answer. The nice thing about letter A, letter B, and letter C, these are already factored, so we don't have to do that work. So we know that we have intercepts at 2 and -5. All right. If we were to multiply this out, if we were to FOIL this, we would get x squared plus 3x minus 10, right? We know that we have a value of a greater than 0. So our parabola opens up, and we can see that we have two intercepts. So let's draw our Sine diagram. -5 comes before 2, so we put that first. We know we're positive, negative, positive. We want to know where is our quadratic less than or equal to 0. So inside here, we're less than or equal to 0. So we'll write out our solution. X is either greater than or equal to -5 or less than or equal to the value of 2. Right, now that equal sign is included because the original inequality was including the equal. Right? If it wasn't there, then we just would have less than symbols and we would have no equality symbol with it. All right, let's try letter B. Now, if we were to multiply this out, if we were to FOIL this, we would get -x² dot, dot, dot. We don't care really what's after it. All we really care to know is what is the value of a. Well, a is less than 0. So I know that I have a parabola that's facing down, and I know that I have two intercepts. Okay, so let's draw our sine diagram. Before -3, we're negative, got positive, and then we're negative. Okay, we're wondering where this quadratic is greater than or equal to 0. So we only care about where it's positive. So the solution for this is going to be x is greater than or equal to -3 and less than or equal to 2. Okay, let's take a look at letter C. Again, it's already in factored form. It means we have x minus 1 times x minus 1. If we were to begin to put that in standard form, we would get x squared, we don't care what comes after, and that is telling us that the value of a is greater than 0, so we know we have a parabola that's facing up. Our x-intercept occurs at x equals 1, so we only have 1, so that's what our graph looks like. Let's do our sine diagram. Now we go back and we read the inequality. We want to know where this quadratic is less than 0. Well, as you can see from our sine diagram, it's not negative anywhere. So this one is no solution. Okay. Moving on to number 2, 2a, b, and c all need to be factored before we can continue on. The only thing we can do when we have a binomial is pull out the GCF. So now we find the intercepts. We get intercepts at x equals 0 and x equals 1. The value of a is just 1. A is greater than 0, so we know our parabola is going up, and we have two intercepts. Draw your sine diagram. Read the inequality. So where is this quadratic greater than or equal to 0? All right, so greater than or equal to. So where is it positive? So this quadratic is positive below 0. So where x is less than or equal to 0, or when x is greater than or equal to 1. Again, for letter B, we just have a binomial. We're going to pull out the GCF. Solve for x. Right. With this quadratic, the value of a is greater than 0. 3. It's greater than 0. It's going up. We have two intercepts. There's our rough sketch of our graph. Let's draw our sine diagram. Be careful here, right? -2/3 comes before 0. It's very important you do the order correctly. We have positive, negative, positive. We want to know, where is this quadratic less than 0? Where is it negative? All right, it is negative between -2/3 and 0. We don't include a line there because the original problem, right, is asking less than. So we only do less than. As opposed to the last problem, we were looking for greater than or equal to, so we included that little line there. That's our solution for letter B. Moving on to letter C. Factor. We have an intercept at x equals -2. The value of a is 1. A is greater than 0, so we know we're pointing up. We know that we only hit in one place. Draw your sine diagram. Get a value of -2. Before and after -2, we know we're positive. Let's go back and read the inequality. So where is this quadratic greater than 0? Well, it's greater than 0 everywhere except where x is equal to -2. So in this case, our solution is just that x does not equal -2. For number 3, we want to make sure that we move everything to the left side first before we try to factor. It's a binomial. We're going to pull out the GCF. The intercepts are at x equals 0 and x equals 3. The value of a is greater than 0, so we know we're going up. And we have 2 intercepts. Let's draw the Sine diagram. Zero and 3. We're positive, negative, positive. And this quadratic inequality, we want to know where are we greater than or equal to 0. So on the Sine diagram, where are we positive? Well, we're positive where x is less than or equal to 0, or where x is greater than or equal to 3. X squared minus 4 less than 0. Okay, this factors to x minus 2, x plus 2. That's the difference of 2 squares. So we have a value of x equals 2 and -2. We'll draw our Sine diagram. Our value of a is greater than 0. We have 2 intercepts. So we're positive, negative, positive. Now, this quadratic inequality is looking to see where we're less than 0, not less than or equal to 0, less than 0. So we're only looking between and not including -2 and 2. Okay, last one on this page. Move the 4 over. Pull out the GCF. Now we're going to get this 2, so we're going to get x equals plus or minus √2. Right. We know that our value of a is greater than 0, so we know that we're going up, and we know that we have 2 roots. Draw your Sine diagram. Okay, we're going to be positive, negative, positive. We're looking where this quadratic inequality is greater than or equal to 0, so wherever it's positive. So we want x is less than or equal to -√2, or x is greater than or equal to +√2. Right. Moving on to the next page, example 4. Right. This is a question formatted the way IB loves to format questions, so this is a really great question. Find the values of k for which the function does the following. Either it cuts the x-axis twice, it touches it just once, or it misses the x-axis altogether. So let's, kind of draw out these scenarios. So what does that mean? That means that we have 2 solutions, right? 2 real solutions. Here we have 1 real solution. And here we have 2 imaginary solutions, or no real solutions. Now, this is where we bring back our knowledge of the discriminant. And in my experience, the IB exam always has a question that has to do with the discriminant. So if we know we have two real solutions, we know that the discriminant is greater than 0. If we have one real solution, we know the discriminant is equal to 0. And if we have no real solutions, we know that the discriminant is less than 0. Right? So we know that the discriminant is b squared minus 4ac. And in this case, we know that that is going to be greater than 0. So let's take a look at our original function. For this function, a is equal to k, b is equal to k plus 3, and c is equal to -1. Because remember, the value of a is the coefficient in front of the x squared term. The value of b is the coefficient in front of the linear term. And the value of c is the constant. All right, so let's fill all that in. So b is going to be k plus 3 squared minus 4 times k times -1 is greater than 0. And let's clean that up. That's a little messy right now. And now we're back to just having a quadratic inequality that we need to solve. So we're going to factor it, we're going to do our sign diagram, and then we're going to determine the solutions. And for this quadratic inequality, we want to know where it's greater than 0. So it's greater than 0 at k is less than -9, or where k is greater than -1. Now for the next one, we know that b squared minus 4ac is going to be equal to 0. Now in this case, be careful. They're asking you, where is this value equal to 0? So where do we actually have intercepts? So we have intercepts at -9 and -1. So in this case, k is equal to -9 and -1. In this case, remember, we're kind of giving generally what the value of k could equal. We know that k can only equal one value because we're only touching the x-axis in one place. But because we don't have enough information to solve for k, we can't tell if -9 or -1 in this scenario is actually going to be the true value. We don't have enough information to eliminate one of those solutions. All right, so moving on to the last one, we have no real solutions. The discriminant is less than 0. So we already know our factored quadratic is k plus 9 times k plus 1 is less than 0. Our values of k are the same, -9 and -1. Let's draw the sign diagram. Right, we have positive, negative, positive. We should have noted that here earlier. All right, in this case, we know it has to be less than 0. So for this guy, we were positive. For this guy, we were equal. And for this guy, we're looking at negative. So for the solution where we miss the x-axis totally, k is either greater than -9 or less than -1. All right, so for this one, I would suggest trying to do a little practice here. We want to look at all three of those scenarios again. When you're ready, restart the video and check your solutions. value of A is greater than 0, and we know that the sign diagram would be plus, minus, plus. Right, now we can use that information to answer part I, double I, and triple I. So for I, we're just looking at the sign diagram to determine where the discriminant is greater than 0. And so where is it greater than 0? Before -8 and after -8. So k is less than -8 or k is greater than 0. For part 2, we want to know where's the discriminant equal to 0. So it's equal to 0 at k equals -8 and k equals 0. And for triple I, we want to know where does it miss the x-axis. So where is the discriminant less than 0? And it's negative between -8 and 0. So those are the solutions for 4A. Let's take a look at B. So in this case, k is either equal to -1 or 1. Let's draw our sign diagram. In this case, the value of A, if we look at it, value of A, right, because if we put this in standard form, let's rewrite this in standard form. So our parabola is pointing down. So we're going to be negative, positive, negative. Okay, now we're ready to answer our questions. So for letter I, you want to know where our parabola is positive. In this first part, right, for letter I, we're positive where k is greater than -1 and less than 1. Part 2, we want to know where's the discriminant equal to 0. So what are our intercepts? And for triple I, we want to know where is our quadratic inequality less than 0. So where is it negative? So it's less than 0 where k is less than -1 or where k is greater than 1. All right, everybody, there was a lot to this lesson, especially as we got into the end. This last page is really important, and when you do sit down to take the IB exam, this page really accurately represents a type of question you might see. So thanks for watching to the end. Pause it, rewind it, play it again if you need to. Have a great day.